last thing. Okay. So now we are going to talk about charge on the colloidal particles. Charge on the colloidal particles. You all know charge is either positive or negative, right? Why is there a different charge? That is the positive and the negative charge. This whatever positive or negative charge which is present is actually due to the charge which is positive or negative is due to preferential adsorption. Obviously, because preferential adsorption means everything cannot undergo adsorption. There is a preference that is going to take place during the adsorption of either positive or negative ion, depending upon what is the surface and all, right? Of either positive or negative ions on their surface. So there is adsorption of generally whichever ion is in excess, okay? That ion is actually adsorbed. Let us look at some examples. FeOH thrice solution is prepared by hydrolysis of FeCl3 solution, adsorbing Fe plus 3, which is positively charged. So what happened when you have FeCl3? It's reacting with water. Then we have a reaction which is FeOH thrice and HCl. So when you look at this, actually, in the FeOH thrice and FeCl3, we have FeOH thrice, which is the fixed part. And we have this Fe plus 3 is to, we also have here Fe plus 3, Fe3 plus is to 3Cl minus. This is the diffused part. That is the fixed part. See, for example, if at all, another example I'm bringing, if at all we have arsenic oxide, it's reacting with hydrogen sulfide. We have As2 arsenic sulfide and water. Okay. In this case, what happens? This is going to actually adsorb the sulfur minus ions. Why? Remember, the ions which are common in both of them are first absorbed. Generally prefer to absorb. If you see in both of them, sulfur ions are common. Where they are common between both H2S and As2S3. Okay. So what happens? Because they are common between both of them, we have As2S3 plus H2S giving rise to As2S3, S2 minus. This is the colloid. Why? It absorbed S2 minus because both of this H2S and As2S3 have sulfide in common. So whenever there are two compounds and one of the ion is common, that is always given first preference in adsorption. Can I clear? So I'm clearing it. Next is electric double layer theory. It is called as electric double layer theory. Also may be called as Helmholtz electric double layer. What happens? We have a colloidal particle. We have positive charges, negative charges. This is fixed layer. This is mobile layer. Double layer theory, right? So the combination of two layers, there is combination of two layers of opposite charges around the colloidal particle. This is only called as Helmholtz electric double layer. So first layer is actually tight, firmly held. It's called as the fixed layer. Second layer is mobile. This is also called as the diffused layer. Because of these two layers, there is potential difference. Because of these two layers, there is potential difference. Sorry, it's not right. So write down, please. There is potential difference between these layers. Okay, I'm repeating. Here, there is, because there is a potential difference between, between two oppositely charged layers, and this potential difference is called zeta potential. ZETA. Zeta potential. This is called zeta potential. There is potential difference. Z is equals to, zeta potential is Z, is 4 pi nu by D. Is the viscosity coefficient. D is the dielectric constant. When electric field is applied. Z is zeta potential, 4, pi, I have given you all three values. This is the zeta potential. I will solve an example on this. Please let me know once you're done copying. I want a message in the chat box if everyone has copied. Then only we are going to the next one. I'm clearing it. Silver nitrate reacting with potassium iodide gives rise to silver iodide and potassium nitrate. And if I have a silver iodide, which is the colloid, I have iodine minus ions around. And I have K plus. So this is the zeta potential. Fixed layer. Diffused. This is what I have already told now. So all the values are here not given, but this is an example I'm showing. Okay. So we just done this, the example alone. I hope you copied. Now we are going to a concept or topic called coagulation or flocculation. You know what is coagulation of blood and all. This is nothing but the process of aggregation. You might get this in your CBSE exam also, the definition. The process of aggregation of colloidal particles into an insoluble precipitate by addition of some suitable electrolyte. You have to add something randomly, they won't coagulate. What do you mean by flocculation then? At low concentration of electrolyte. The aggregation of particles is known as flocculation. Okay, but this flocculation is this flocculation, no, can be reversed by shaking, whereas this is coagulation, no, coagulation cannot be reversed. by shaking. See, these are all very basic, but you have to know everything for the applications in the exam. So the stability, we know lyophobic are more stable, okay? The stability of lyophobic colloids is actually due to the presence of charge on the colloidal particles. Okay. If at all the charge, whatever is there, is removed, the particles will lose the stability. They all will come near to each other. They all settle down due to gravity and they coagulate. Okay. So if you remove the charge, if charge is removed, due to gravity. Let us, after copying this, we'll understand what is a coagulation value. So I'm clearing it. Coagulation value or flocculation value. So coagulation or flocculation value. What is this? The minimum concentration. The minimum concentration of electrolyte in millimoles required to cause coagulation of 1 liter of colloidal solution. It is expressed in terms of millimoles per liters. What is coagulation value? Millimoles of electrolyte volume of solution in liters. See, coagulation will be carried out in 2 methods. Coagulation is carried out first by electrophoresis, that you already know. by mutual precipitation. Mutual precipitation. What is mutual precipitation? Here, oppositely charged solution, they are mixed in proper proportion to neutralize the charge on each other, causing coagulation. That is mutual precipitation. That is the second method. Third, by prolonged dialysis. By prolonged dialysis, traces of electrolyte present in the solution are removed completely and colloid becomes unstable and gets coagulated. By cooling. By cooling, certain solution can be coagulated by lowering temperature. Why? Because at low temperature, the dispersion medium molecules, they do not exert sufficient force on dispersed particles. So here the Brownian movement becomes less effective. By boiling. Means increased collisions between the solution particles and water molecules removed the absorbed electrolytes. This takes away the charge and helps them to coagulate. See clearly, what can you see from all of it? If you remove the charge from any solution by any means, we are able to let them go coagulate. Also, last I'm writing here. Maybe I'll write here. By addition of excess of electrolyte, colloidal particles precipitate. That's all. These are the 6 methods. We'll be done with today's, we'll be done with this chapter today. So let me know if you're done. I'll clear the screen and we'll go forward. Okay. Remember that coagulating power is inversely proportional to coagulation value. We are comparing comparison of relative coagulating power of two electrolytes for same colloidal solution. Then what will you do? I'm writing coagulative power as Cb and this as Cv, okay? So coagulating power of electrolyte A, coagulative power of electrolyte A by coagulative power of electrolyte B is coagulation value of B by coagulation value of A. Okay. Very important thing is factors affecting coagulation. One, the nature of solution. Two, nature of electrolyte. Three, that's it. These are the two factors. Okay, so lyophobic colloid can easily coagulate because it is less stable colloid. Lyophilic hardly coagulate by addition of electrolyte. Why? Due to the protective layer of the dispersion medium surrounding the colloidal particles. Next is nature of electrolyte. In equimolar electrolyte, strong electrolyte have coagulating power greater than weak electrolyte. Example 0.1 molar NaCl has greater than 0.1 molar acetic acid. After I'm clearing the first. That rule I was talking about. So what happens is, according to according to according to this rule, greater the valency of coagulating ion, greater is its power to precipitate. In case of positive charged solution, coagulating power of anions is in the order of, very important, FeCN64 minus, greater than phosphate ion, greater than sulfate, greater than chlorine. In case of negative charged solution, power of cations is aluminium, barium, sodium. These are all questions asked. We are done with the coagulation part. Next, we are understanding how do we protect the colloidal solutions. Okay, so we have something called goal number. What is this? It's the minimum amount of the protective colloid in milligrams, which when added to 10 ml of a standard gold solution is just sufficient to prevent a color change from red to blue on addition of 1 ml of 10% NaCl solution. Remember, smaller the gold number, greater is the protecting power. So what can I write it as? Gold number is this is gold number. See what happens here, generally lyophilic colloids are more soluble and much more stable than lyophobic colloidal solutions that we already know. Somewhere I wrote. Reverse. Oh, correct. So lyophilic solutions are more stable than lyophobic because of the extensive solvation of lyophilic. Lyophilic water loving. So they have so much of water solvation. They are going to form a protective layer outside this particular colloid, and it prevents it from forming any other associative colloids like reacting with anything. Whereas lyophobic colloids, they can easily precipitate when you add a small amount of any electrolyte. They can be prevented from coagulation only by addition of some lyophilic colloid. So because of this formation of a protective layer by lyophilic solutions outside the lyophobic solutions, this process of protecting the lyophobic colloid solution is only called the protection of colloid. And the lyophilic colloidal solutions here are called protective solutions. The lyophilic are only called the protective because they protect the lyophobic. Okay, so I'm just clearing it. So what is the uses of this protective action? Gelatin is actually added in preparation of ice cream to protect the ice particles. Protergol on argyrol is a silver solution. It is protected by organic material, which is used as eye drops. Where do we use all these colloids? Actually, colloids, they also include emulsions. They have so many uses in our daily life. They are used in our medicines. Wide variety of medicines are actually emulsions. So these colloidal medicines are easily absorbed by our body tissues. because of large surface area. Okay, so they are used in medicines. These colloids are used in medicines. And milk of magnesia is an emulsion. Remember, it is used for your stomach disorder. Colloidal gold, it is used as an intramuscular injection. Colloidal sulfur is used in germicides. And it's very important. I don't know if the last cube, but yeah, write down argyrol. Argyrol is actually a silver solution which is used as eye drops. And colloidal iron hydroxide is given to arsenic poisoning patients as it absorbs the arsenic and then the whole poison is over. It is used in tanning, it is used in photographic plates, rubber plating, sewage disposal, formation of deltas. It's used in artificial rains, nanomaterials, disinfectants, so many. Actually, there is this, the size and shape of colloid particles are actually not seen with your eyes. So to determine this, we use something called STEM technology, which is with the help of electron microscope, we see it. How do we see? Scanning, we can use scanning electron microscope, transmission electron microscope, scanning transmission electron microscope. All these we can use. Okay, let's talk a bit about emulsions and gel and we are done with the class. The whole chapter also. So emulsion and gel. Emulsion means emulsion. It is a pair of immiscible liquids, that's it. Which like water and oil, okay? Emulsions are unstable and are separated into two layers on keeping still. We add emulsifying agent to stabilize the emulsion. Why? What do you mean by stabilizing emulsion? We have a layer is formed actually. How does a layer forms between this dispersion phase and dispersion medium? Milk is an emulsion. They ask so many times in NEET, milk is an emulsion. What is the dispersed medium and all? Dispersed phase is liquid fat. And dispersed medium is liquid water. And this is the agent, emulsifying agent. The next one is called demulsification. This is separation of an emulsion into its constituent liquids. This is called demulsification. How do we get this done? By freezing, heating, removal of emulsifiers, centrifugal action, and so on. See, depending on the nature of the dispersed phase and dispersed medium, we can say two types of emulsions. One is oil and water emulsion. Two is water in oil emulsion. Okay. And also we can convert this conversion of emulsion of oil in water. We can convert into water in oil and all of this. This is called inversion of the phase. Actually, how do you identify whether it is oil in water or water in oil? what you'll do is a dilution test. An emulsion you can dilute with any amount of dispersion medium, while the dispersed liquid uh, forms a separate layer. So if you a few drops of water added to the emulsion are soluble in it, it is oil in type. I'll just write it maybe. Types of emulsions. I'm clearing this. We have two types of emulsions. We'll be just done in the next 10 minutes with the chapter. One is oil in water. Next is water and oil emulsion. Okay. How do you identify? First, dilution test. Next, dye test. Electrical conductivity test. What happens in each of it? Dilute the emulsion with any amount of dispersion medium while dispersed liquid forms separate layer. Okay. If few drops of water added to the emulsion are soluble in it, it is called oil in water. If immiscible, it is water in oil. How do we do dye test? Small amount of oil soluble dye gives uniform color to emulsion. Then it is water and oil. Otherwise, oil in water type. Electrical conductivity test. If you add electrolyte and conductivity increases, it is oil in water. Otherwise, it is water in oil. We are done. So emulsions also we use in disinfectants like phenyl, Dettol. When you mix with water, immediately they don't mix up, right? Digestion of fat in small intestine also it occurs easily due to emulsion. We use milk as an emulsion. Cleansing action of soap also is due to the formation of emulsion. In metallurgical processes, we use emulsions. Last part, we have gel. That's it. Gel is like one slide I'll write and we'll be done with the day and the chapter. And you all will have tests tomorrow, obviously, on surface chemistry. Next we have gel. Gel is example. Gelatin dissolved in water, forming a colloidal solution, which, when cooled, sets into a jelly. Gel actually has honeycomb structure. Example of this gel again is silicic acid, sodium oleate, solid alcohol, and gelatin. See, there are types of gel. Elastic gel, like gelatin, starch, agar. We have non-elastic gel, which are rigid. We have elastic properties. Silica gel. Yeah. Write down if you're done. Let me know if you're done. If you're done, we are done, and I'll see you again next week. Please do the exam. If you all copied, we'll end the session. Thank you. Good night.